Okay, this sheet is just asking us to look at some force diagrams, at least on the front side, answer a few questions about its motion, and draw a qualitative velocity time graph. So looking at the first one, we see that these two forces, they aren't labeled, but up and down are both equal in magnitude and opposite in direction, so those are balanced. That causes this to be a constant velocity. Because this is only if it's accelerating, that's not applicable, done. The qualitative velocity time graph, you have to look at a couple pieces of information. It's constant velocity, so it should be a horizontal line on this velocity time graph, but it tells us it's moving to the right. So therefore, that is a positive direction of motion, so that should be a positive velocity. And that should look horizontal. The next one, we see that the top and bottom arrows or forces are also equal in magnitude and opposite directions, so it is not accelerating vertically. But then we look at the horizontal forces and we notice that we have a net force here. They are not balanced, so this is accelerating. Since we know it's accelerating, we have to answer these next two. If it's accelerating, the direction of the acceleration. From class, from that activity we did, we realized that the net force is in the direction of the acceleration. So by looking at this diagram, my sum of the two forces, if I were to label this 5 and 2, and this 5 is to the left, so negative 5 and 2, I add those together. Negative 5 plus 2 is equal to negative 3. It's almost like saying this amount is left over. That net force is drawn. That net force is to the left, so therefore the acceleration is to the left. The object is told that, or tells us that it's moving to the left. If it's moving to the left and accelerating to the left, back to our Unit 1 idea, if they are in the same direction, direction of motion and direction of acceleration, that means this object would be speeding up. On that velocity time graph, we know we're moving to the left, so that means we're in our negative velocities, and speeding up, so we don't know our initial velocity, so we can really start anywhere, but that should be getting to a larger magnitude for its speed. So speeding up, that is what that one would look like. You should be able to finish the rest based on those, but to take a look at the back side, it's asking for some force diagrams to actually be drawn. So not just analyzing those qualitative force diagrams, but now actually drawing some. So we have to use our rules that we looked at before. Notice it says, in each of the following situations, identify the system by circling it, represent the object with a particle, aka a dot, and sketch all forces acting upon the object, make the length of each vector represent the magnitude of the force, and label each vector with the type and use on by notation. You must do all of those things to kind of have accomplished fully satisfying, or to satisfy fully doing this homework assignment. So for number 1, the object lies motionless. I'm going to circle my system. My system is the box, and I'm going to represent it with a point particle. Just like we did on the notes, go through your 4 forces to see what applies. First force, force of gravity on the box by Earth. And then I go through my next list. I have normal, friction, and tension. This is sitting on a surface. So therefore, those electromagnetic repulsions that are happening from the electron shells are going to apply a force perpendicular from that surface on the box, and that would be pointing straight up. The fact that it's motionless is telling us that this box is not accelerating, so I need a balanced force diagram. Coming back, this would be Fn on box by table. You could say table or surface, whatever. We don't really have a specific one for this one. And any other forces, no tension, no strings are on it, and no friction. It is not moving or intending to move. So therefore, that is our final force diagram for that one. Make sure you go through these, circling your systems and following those directions about making the magnitude size, or the magnitude of the arrow specific, labeling them with on by notation, and kind of going with that, or that force of gravity, normal force, labeling with the type as well. All right, let me know if you have any other questions.